Here is an explanation for final exam question number 85 in Physics Demystified, 2nd edition. If you have the printed book, you'll find this question on page 534. We're talking here about a MOSFET. That acronym stands for Metal Oxide Semiconductor Field Effect Transistor. The question is asking us how the forward breakover voltage specification affects the performance of the device. Well, remember what forward breakover voltage is. In a semiconductor diode, here's the symbol for that thing. Forward bias occurs when the electrons flow against the arrow or the conventional current flows with the arrow. In order for conduction to occur in a semiconductor diode like that, which contains a PN junction, the forward voltage must exceed a certain minimum value, right around 1/2 volt. Depends on the type of semiconductor material, but it's around 1/2 volt. Some of them it's a little more than 1/2 volt, some of them it's a little less. But in order for forward breakover voltage to have any meaning, we have to have a PN junction, a junction between P and N-type semiconductor materials involved. Well, this is a simplified functional diagram of a metal oxide semiconductor field effect transistor. In this particular case, we have P-type material which forms the substrate, that is the sort of like the foundation on which this device is built. And we have, I'm sorry, I misrepresented this when I drew it. Okay, now it's correct. The substrate is simply the foundation. The N-type material here forms what's called the channel, which is where the current flows through between the source and the drain. The gate is sort of like a valve. It regulates the amount of current that flows through the channel, and it does that by producing an electric field through an insulating layer, also known as a dielectric. That's how this works. The actual electrodes, if you'll notice, there is no PN junction involved with the electrodes themselves. There is a PN junction here. Now, there is also something called a P-channel MOSFET, in which case the P and N-type materials are simply reversed, but it works the same way, basically. The current goes from the source to the drain, and the gate regulates it, but there isn't any PN junction involved in that process. So there is no such thing here as forward breakover. It's a completely irrelevant specification in a MOSFET. So our correct choice for this, to answer this question, is E. The premise is wrong. A MOSFET doesn't exhibit the forward breakover phenomenon at all because it doesn't contain a PN junction. Well, it does, but it doesn't. This junction doesn't have anything to do with the signal path. The signal path just goes through that channel.